Hey, good morning, or good whatever time it is for you. I just want to explain real quickly how to figure out what the domain of a logarithmic function is. And this is sort of based on just what the concept of a log function is in general. Okay, so I've got a graph here of the function y equals 10 to the power of x. So I take the number 10 and I raise it to the power of x. So, 10 to the power of negative 2 is some small number over here. That's equivalent to 1 over 10 to the power of 2, which is 1 over 100, which is 1/100th, some tiny number. If I take 10 to the power of 0, I get 1 because anything to the power of 0 is 1. If I get 10 to the power of 2, what do I get? I get 100. It's way up here, right? Okay, so that's an exponential function, y equals 10 to the power of x. I'm raising the number 10, this base 10, to some power. And I can raise 10 to any power between negative infinity and positive infinity. So that's cool. But what I can't do is um, make 10 into a negative number. I can't raise it to some power and then it suddenly becomes negative. You know, because you might think, well, 10 to the negative 100th. What about that? Well, that's just a very small number. That 10, 10, 10 to the negative 100th is equivalent to 1 over 10 to the positive 100th. So it's 1 divided by a very large number, which is equal to a very tiny number, but still positive. It's not negative. So there's no power I can raise 10 to in order to make it into a negative number. I can make it into a very tiny number. I can make it very, 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 very close to 0. Um, but I can't even make it 0. But I can make it something very close to 0, and I definitely can't make it anything negative. So the range of this exponential function is every real number that's greater than 0. Well, the logarithmic function is the inverse of an exponential function. So this particular log function, log base 10 of x, is the inverse of this particular exponential function. And you can see that the domain, or the possible x values, is the range of the original exponential function, right? Okay, so that's kind of the visual. Let me just go over the definition of a log again in a different way, and then I think this whole business about the domain of a log function will make sense. So here's like a semi-formal definition. If you're making these assumptions that b is greater than 0 and b is not equal to 1, and y is greater than 0, if b to the power of x equals y, then log base b of y is x. Now, the way I remember that is just to think of a very concrete example. If 10 squared equals 100, then log base 10 of 100 is equal to 2. In other words, I have to raise 10 to the power of 2 to make it into a 100. Because the log is asking the question of, take my base, whatever it is, 10, e, 7, 2, whatever, take this base, and then it asks the question, to what power do I have to raise this base in order to turn it into this number of which I'm taking the log? And then the answer is that power. So log base 10 of 100 equals 2 is saying that if I want to take this base 10 and turn it into a 100, I have to raise it to the power of 2. Consequently, the domain of a log function in general is you can't take a log function of anything that's less than or equal to 0. The domain has to be greater than 0 in general, because again, if log base 10 of 100 is 2, meaning I have to raise 10 to the power of 2 to equal 100, well, if this is a negative number, say I was like log base 10 of negative 3, well, there's no power that I can raise 10 to in order to turn it into a negative 3. I can get it very close to 0 on the positive end, but I can't turn it into a negative number. So in general, this number here that you're taking the log of, whatever the base is, you can kind of ignore the base. The base has its own kind of restrictions. Can't do base 1 or whatever. Um, you Whatever the base is, the number of which you're taking the logarithm has to be greater than 0. So we can take that fact and just figure out the domain of a couple of simple log functions. So in general, if it's just, y equals log, let's say base 10, so we don't have to write the log, the base, y equals log of x, the domain would be x has to be greater than 0. And that, all real numbers that are greater than 0 will count. Now, if you take something that's a little bit more complicated than just x, then you have to figure out, well, what will make this inside of the function greater than 0. So for example, if we have this function f of x equals log, and then there's no base stated, so we can assume base 10, log of 2x plus 7, well, we simply have to ask ourselves, what's going to make this inside greater than 0? Because we're taking the log of all of this. All of this has to be greater than 0 in order for it to work. So we simply have to say 2x plus 7 is greater than 0, and under these conditions, this log will be valid. So we just simply solve this inequality. 2x is greater than negative 7, and divide by 2. So the domain would be all real numbers such that x is all real numbers x such that x is greater than negative 7 halves, also known as negative 3 and a half. Yes, yeah, yeah. Yeah. So that'd be the domain, and you could say, um, you could say, negative 3 halves is less than x is less than infinity. You could say, you could put it in set notation, if you want, like x, I'm trying to remember, yeah, x is in the set of all real numbers, such that x is greater than negative 3.5. Something like that. I'm just gonna do this very simple form. I'm not sure what notation you're gonna need to express the domain in, but you can review the different kinds. There's interval or set notation or inequality notation. Just a simple, all real numbers as long as x is greater than negative 3.5. All right, so let's try another one. F of x is the natural log of x plus 2. Natural log is log base e. Again, we don't need to concentrate on what the base is. The domain of this function is all real numbers such that the inside here is greater than 0. So we can just say x plus 2 is greater than 0. Subtract 2 from both sides to solve that inequality. So x must be greater than negative 2 would be the domain of that function. And so if if this is the function log base 10 of x, but say it were log base e of x, then this function would just be shifted back by 3 or by 2. So it would just be, instead of going through the number 1 here, I don't know. That's kind of sloppy. That's not exactly right, but anyway, just imagine the original function, and then you've got this horizontal translation where it's going back to from where it is. Basic idea. All right, there we go. That's the general idea of the domain of log functions. And for each individual situation, there may be some other factors to consider. If you're taking the log of a if the inside is a rational expression, there's other things to consider. Don't divide by zero, etc. But this is the general idea, the basic intro of the domain of log functions. All right, good luck.